This is the video that I'll put in the middle of my web page. To get to my web page, you go to parkview.net. When you go to parkview.net, guys, the first thing it's going to do is it's going to redirect you. It's going to redirect you to a county website. Then from the county website, go to teacher web pages. Teacher web pages, go down to math. In math, my name is Robert Hill. Click on that. This web page will come up. Later on in the day, it'll be right here. One of them will be my Algebra 2. One of them will be y'all. It'll look like this. The opening of it will look like that. I'll use this right here, this Chapter 1 CC Algebra 1 Review. I'll use that as the page that pops up or whatever. Okay. Yesterday you got a review. Okay. That review looked like this. Okay, it says write an inequality or write an equation or inequality. The difference of p and 5. Remember, the difference means what? Subtract, so the difference of p and 5 would just be p minus 5. Okay, the product of 6, what's product? Multiplication. And n more than 2. N more than 2. N plus 2 or 2 plus n? 2 plus n. Whatever's after more than goes first. So this is 2 plus n. The only way I can multiply something by 2 plus n is if I do what? The 2 plus n. So 6 times 2 plus n looks like that right there. All right. 10 is, what does the word is mean? Equals. So 10 equals 9 less than the quotient of x and 7. So x over 7 minus 9 equals 10. Now, if later on in the test, and like I said, this is a review, it's similar to some of the problems that are on the test. Tomorrow morning I'll get up here about 6:45 and you can come in here if you have some questions on the problems that I'm going to show you later today that you can practice tonight that are real similar to questions that are on the quiz as well. But anyway, somewhere else on the quiz, if you were asked to solve this problem, x over 7 equals 19, what's the inverse of dividing by 7? So x would be whatever 19 times 7 is. Did anybody figure out what that is? 70 and 63 is 133, I believe. All right, solve the following equations for x. Remember, when you're solving for x, you got to get your numbers on one side, variables on the other. I just wanted to put one of these in there so that we had a couple of these. 6x minus 15 equals 13x plus 11. Certainly, you don't have to do all this in one step. It might be quickest for you to subtract 6x from both sides. And so that gives me, that cancels out. So negative 15 equals, what is that, 7? 7x plus 11. Subtract 11. So x equals negative 26/7. Guys, that's a perfectly good answer. Nothing wrong with that. Why is there nothing wrong with this answer? Because you can't reduce it. Guys, I'm not going to expect that you change that to negative 3 4/7 or whatever it is, or negative 3.1. Right. Perfectly good because it's reduced. Over here, what property is this? So the first thing you change this to is 6 minus 12x plus 5 equals 7x minus 9. We had a couple of problems where this happened. Remember, guys, this 6 and 5 are both on the left side of the equal sign. Since they're both on the left side of the equal sign, the first thing that I do to them is what? Add them together. So 6 plus 5 is 11. So now I have plus 11 equals 7x minus 9. So now that problem goes back to just like this one. So it's a matter of just moving stuff around. Just taking 12x and adding 12x to both sides, or moving 9 the other way, or 7x. Guys, you just got to make a choice of doing something. You got to pick something to move it. I chose to move 12x to the other side, so this guy right here ends up being positive. Maybe you moved the 7 this way. If you moved the 7 that way, you would have negative 19x. As there's going to be several things that you can move right there. So 20 equals 19x. So x is 20 over 19. Again, perfectly legitimate answer. Nothing wrong with that problem. And I needed that question on those two right there. How I get them or anything like that. Find the quotient of the two solutions below. So what I'm expecting you to do is work these two solutions and then do what to the answers? Divide them. Very good. So it's just kind of another way of asking you to solve a problem. So what I do here is I say 5.2 minus x equals 3.2. So the first thing is I got to get an answer to this question right here. Then I got to get an answer to y over 3 plus 6 equals 10. Then when I get those two answers, notice what it says. It says find the quotient of those two. It's a lot of times how the questions are asked for of you. Yesterday we worked some problems, and when we worked the problems, it was just a proportion question. Guys, there's questions just like this on your test tomorrow. And if you're not careful, you can be intimidated by the way the questions are set up as much as how you solve them. Okay? What I mean is this. Tomorrow there's some questions. There's a table. There's tables just like this. I mean, I found this table by searching the internet saying the speed of different animals. And that table is reduced down on the test. And it says, compare the speed of I don't know, I'm just making this up, guys. It says, compare the speed of a squirrel to the speed of a giraffe. Is 12 over 32 a good answer? No, what will you need to do to that fraction? Reduce it. When you take your calculator, you guys it's happening to some of you already. You take a calculator real quick and you go 12 over 32 and you get an answer which is 0.375, guys. I'm telling you now, I've seen the test. I know what it looks like. 0.375 isn't an answer that's on the test. It's written in a fraction that's reduced. Instead of being 0.375, the test says 375 over 1,000, and then they reduce 375 over 1,000. But you can't just punch buttons on your calculator and think that's going to magically give you the right answer. Here's a little workaround. You could take all your answers and convert those fractions into decimals that way too. You understand what I'm saying there? Like the answer to number 1 is 1/2. You take your calculator and change that 1/2 to what? 0.5. If your answer, if you like that decimal answer and you want to use 0.375, then go to A, B, C, and D and realize you could convert those. If I look at an elephant which can run 25 miles per hour, and a black mamba snake which can run 20 miles per hour. So I would just have 25 over 20. I just took the two numbers right there. The test says an elephant is, reduce for me, 1.25 times faster than, what did I say, an elephant and a snake or something like that? It says the elephant is 1.25 times faster than the snake. 2 questions later, it says, how much, or compare the speed of the black mamba snake to the elephant. So 2 questions later, it's not 25 over 20, it's 20 over 25, which is 4/5. You don't like that because when you took your calculator, you got the answer 0.8. So what you did to all the answers, the A, B, C, D answer, is you changed all those fractions to decimal. And then you got your answer. But guys, it's still simply nothing more than a proportion. So don't get intimidated by the question, because I keep asking you this same question about percents all over the place, or excuse me, about fractions all over the place. So what I wanted you to do here is subtract 5.2, get negative x equals negative 2, so x equals 2. Come over here, subtract 6, get y over 3 equals 4, multiply both sides by 3, and get an answer of y equals 12. Then the original question says, find the quotient of the 2 solutions. So the quotient of the 2 solutions is 2 over 12. Is that a good final answer? 1/6. That's a good final answer. 1/6. How could the test have an A, B, C, D? This time, they're trying to find out if you can change from a fraction to a decimal. So my calculator says 0.16, or excuse me, the test says 0.16. Put your calculator real quick. 1 divided by 6. Hit enter. It doesn't say 0.16. It says 0.16 repeating. So don't get tricked by that. That's 0.16 repeating. Is that okay? 1 divided by 6, see what it is in your calculator. It says 0.16 repeating. That's not 0.16. If they want you to write 0.16, they'll say round it off or approximate it or something like that. And even if they say approximated, 0.16 repeating would approximate the what? Yeah, 0.17. So it would approximate the 0.17 anyway. Guys, that's one of the things you do in a high-stakes test, is I find out, are you just punching buttons on a calculator, or is it you know what you're doing, you solve the problem, and you use a calculator as a tool to help you solve it more efficiently. But you're not letting the calculator think for you. You're still doing the thinking. All right. That takes us to 4. All right, question number 4 here. This is one on our quiz in this chapter, guys. We did not do very well on this. Several of us missed this question because we thought that was addition. Guys, it's not addition, that's multiplication. What's the inverse of multiplying? But in this particular problem, dividing by 6 doesn't do me any good because I have 24/5 divided by 6, so that's kind of hard to deal with, or it's kind of complicated looking. So instead of dividing by 6, I'm going to multiply by the reciprocal of this number by the variable. What is the reciprocal of -6? Okay, so I'm going to multiply by, let's say it right, not 1/6, -1/6. Because when I multiply by a negative times a negative, that gives me a positive. So if I multiply this side by -1/6, now I multiply this side by -1/6, and I get x equals -4/5, -24/30. That reduces, -24/30 reduces to 3 goes into both of them, 8/10, which also reduces to 4/5, because 8 goes into them. or not 8. What is that? Negative 24.
Yes, you're right.
30 is, yeah, no, 8 doesn't go into 30.
Yeah, 6. 6 goes into both.
6 goes into both. Thank you. Oh, look what I did. Keep up with your signs. Again, 2/3 x equals 15. Where in the world did I get 15 from? That doesn't have a 15 in it, but I wrote 15 right here. I subtracted my 7. So this time it's 2/3. Again, what's the reciprocal of 2/3? 3/2. I tried to stress this issue to you as we went through the chapter. Guys, as we went through the chapter, one of the things I tried to get you to see was the word that we dealt with was reciprocal. How do you find the reciprocal of a fraction? You flip it. Everybody good? So when I multiply a number by its reciprocal, that gives me 1. It always gives me 1 when I multiply. Look, I'm multiplying here. When I multiply a number by a reciprocal, it gives me 1. Always will be the case. The reason that's important is because that gets x by itself. Now, let me ask you this. When I write x, is x really by itself? No, there's some implied things here. There's an implied 1 that we don't write out front. There's a 1 to the exponent. There's an imaginary 1 that's in the denominator. So when I say it's by itself, remember, there's a lot of stuff there that's around it that you don't see, but that's what allows me to get the correct answer. The correct answer is 45/2. Good answer? Yes, that's a good answer. It's reduced. It's reduced. You don't have to change that to 22.5. Could it be changed to 22.5? Yeah, and the answer is they change it to 22.5. Or they say 22.5. But they can't do all 3 and make you pick the one because they're all 3 the same value. Does that make sense? This is more a preview than it is anything else. I just wanted to make sure we understood some words here. Each one of these things here is a term, so there's 3 of them. The middle coefficient, remember it's a coefficient, it's a variable, and it's an exponent. I'm just having some words here. So the middle coefficient is 5. The exponent of the middle thing is 1. Add the number of terms to the exponent and subtract the middle coefficient. The exponents of the terms are 3 and 1. So exponents are 3 plus 1 and 0. Just remember, any number to the 0 power is 1. But anyway, it says add the number of terms to the exponent and subtract the middle coefficient. So there's 3 terms. There's 3 terms to the exponent. I guess the exponent of that is 1. So there's the 1, the number of terms, and subtract the middle coefficient. The middle coefficient is 5. So I guess I should have 3 plus 1. 3 plus 1 minus 5. 3 plus 1 minus 5 is -1. If you didn't miss that, don't worry about it. I'm just trying to show you some weird ways that the questions can be asked. Again, this is more just preview than it is reading. 14x squared and 11x squared. What's 14 plus 11? X squared. Negative x and 5x. Negative 1 plus 5x is 4x. And then negative 3 plus 1. So your answer, guys, this is the sheet that I gave you yesterday. Your answer to number 6. You guys that are trying to see these numbers on the board, you don't necessarily have to do that because you can look down at your own work, is 25x squared plus 4x minus 6. Don't forget what property? Over here, distributive property, okay? 3x plus 7y minus 5 minus 6y. A negative and a negative is a plus 4y and minus 10. So if I went through and I combined my like terms, there's 3x, 7y, 4y, and negative 6y is 5y, and negative 5 and negative 10 is negative 15. Guys, like I said, this is the first 6 problems. The other 6 problems I'll go over on my next period class, and then I'll put these 2 videos on YouTube, and then they'll show up on my website. Okay. Tonight, you need some more practice. You're one of those people that doesn't feel real comfortable about all the problems. On page 54, you start on page 54 in your book and 1 through 24. Like I said, I'll be here at 6:45 roughly tomorrow morning, and I'll answer one. I'll answer any questions that you might have. When we go to that page 54, the first question is 5 minutes in 1 day, and it asks us to convert it to the number of seconds that something is reduced per hour. It asks us to convert it to seconds per hour. This is like that. Remember the 40-yard dash one that we figured out how many miles per hour a 40-yard dash was? We figured out, what else did we do? We did a pitcher throwing a baseball at 100 miles per hour. Here's another one of those conversions. If I'm going to go from minutes a day to seconds per hour, I got to set this up and eliminate some things. So the first thing I need to do, I need to change this days to a number of hours. So to change it to a number of hours, I go up top, I multiply it by 1 day, which is how many hours? 24 hours. And then I got to change this minutes to seconds. So what do I have to do there? I got to go 1 minute is what? 60 seconds. So watch what happens here. So now I start canceling out stuff. I can cancel out minutes and I can cancel out days, but then I'm left with 6 times 5, which is 300 seconds over 24 hours. And so I did it. I converted from minutes a day to seconds per hour. But the problem is this a good final answer? Somebody with a calculator, figure out what 300 divided by 24 is. Get 1.25 or 12.5? No, I got 12.5. You should have got 12.5. Question number 1 on page 54 asks you to convert from 5 minutes a day to the number of seconds per hour in 2 hours. If this is 1 hour, if it's 12 seconds per hour, what would it be in 2 hours? So the answer to number 1, so you get started, is 25 seconds. Again, don't be intimidated about how the problems are set up. And then understand also, I just want to talk to you about this, in the proportion problems, make sure when you set up your proportion, whatever that proportion might be, you got the same unit of measurement. You with me? Or if you need to convert, this is how you convert. Or you get this thing make sure you get the same side in the same place. So if I have two different objects and I write one side of one figure over another side of the other figure, it's got to be corresponding sides. You can't just pick any two numbers out of the pictures. They have to have some relationship to one another. And then, is there more than one way to set up a proportion? Set it up. Yes or no? Is there more than one way to set up the proportions that we've been setting up the last few days? Yeah. Okay. But when we cross multiply, do we end up multiplying the same numbers? Yeah. Guys, you got to make sure that when I have two different objects, if I have a proportion and for whatever reason, if I write A is to D, I can't then pick something from the second figure. If I said A is to D as maybe B is to E, I can't write E over B because I'll cross multiply incorrectly. I've got to take them in the same order. So if I said A is to D, then I got to come back over here to this first triangle and write B is to E. So if for whatever reason you accidentally wrote A is to B, can you do that? Sure. I wrote A is to B, but then when I do that, I got to go to my other figure and take them in the same exact order. A is to B as D is to E. So when I cross multiply, what do I cross multiply here? I get A times what? E. Here in this one, what do I cross multiply? A times E. So it doesn't matter that you set it up a certain exact way. What matters is you set it up in the same order. And you get sides that correspond to each other. I have to pick A and D. And then what was that word that we used for that? If two objects are congruent, they're the same. What was the other word?
They're similar.
Similar. If the two objects are similar, then their angles are the same and their sides are proportional. That's what similar means. Do we remember the symbolism for similar?
The little squiggly line.
Little squiggly line. All right. We're going to stop right there. Guys, what we're now going to do is